Hi and welcome to Redshadow Hacking, and one walkthrough of many to be released about ethical hacking. In this series, I'm dabbling in the world of CTFs, Capture the Flag challenges, which are aimed at making you and me better ethical hackers. With the knowledge I will share in this series, you'll be able to improve not only your Linux skill set, but also your critical thinking as an adversary in terms of exploiting different systems. Let's make sure we are prepared by downloading a hypervisor if you don't have one already. I would suggest either VirtualBox, VMware Workstation, or Microsoft Hyper-V. To make it as easy for you as possible to follow along, please download and install either of these Linux distributions as your attacker machine. Kali Linux, Parrot OS. Once installing the attacker machine is finished, please make a full update. Since these are Debian-based attacker systems, open a terminal and use this command to update. Sudo apt update and sudo apt dist-upgrade -y. Today's victim is going to be the Matrix 3 machine from vulnhub.com. Please download and install the machine as a separate virtual instance. Make sure that before you start your machines, your network settings are set to NAT. When these settings are applied, start the machines and let's begin. As this is a Capture the Flag challenge, our objective is to capture one flag. This flag is usually a text file called flag or a string with the word flag in it. Before we continue, if you haven't already, please make a directory inside your home folder called vulnhub. Inside the vulnhub directory, please make a folder called Matrix 3. Finally, enter that folder. We need to stay organized during a Capture the Flag challenge, so we will work from this folder from now on. The first step will be to make sure that you know your own IP address by opening a terminal and typing IP-add. Take note on which subnet you are residing. In my case, my IP is 192.168.148.130, which means my subnet is going to be 192.168.148. So let's do a quick Nmap scan to check our surroundings and see if we can find our target machine. Nmap 192.168.148.0/24. The 0/24 in the last octet simply tells Nmap to scan all possible IP addresses in that octet. When the scan is finished, I can make out that the target resides on 192.168.148.133, since this server is hosting HTTP. Let's single out the target and make a deeper Nmap scan. Nmap -A -T4 -P 192.168.148.133 in my case. This might take a minute, but when it's done, the result gives us one HTTP server on port 80 and one on port 7331, as well as SSH running on port 6464. The first thing I want to do is check out the web page running on port 80. I'll do that by simply pasting the IP address of the target in my browser's URL field. This is what the web page looks like. There are no login prompts, no visible links, nothing to really go by here. So let's take a look at the other port, port 7331. Simply add :7331 to the browser's URL. Okay, so here we are prompted to log in. Well, we don't have any luck here because we don't have any credentials to use. We can try admin or admin password, but we won't get in. So let's head back to the original page. Let's now view the page source. We do find a link here, hinting to an /assets directory. And within that directory, there's also a /img directory hosting at least one PNG file, as we can see in the link. Let's open the directory /assets in the browser first and peek inside it. After opening the assets folder, we find a few more folders inside, one of which is /img. The others seems to be web language folders like CSS, Java, and so forth. Inside the /img, we find the picture called Matrix Can Show You the Door.png. Let's download the image. Nothing seems to be out of the order with the image. Using XF tool to look at the metadata gave us nothing. I also used steghide to see if the image is hiding other data. But actually, our next step is in the file name itself. Matrix Can Show You the Door, the picture is named. Let's add matrix to our URL instead of assets. Now we can see all these directories, but where to go from here? Well, it's kind of a guessing game from here. We know that we are working on a matrix target and a little bit about the movies. How about we try to spell by pressing the folders? Let's start with Morpheus. Nope. There's no M to press. How about Trinity? Also a big fail because there's no T folder. How about Agent Smith? I guess you figured it out by now, but here we go. Let's try Neo. N-E-O. Okay, we made it a bit further, but we are now presented with folders named 1 through 9. The author of this VM is Unknown Device 64, and he seems to be putting 64 all over the place. So let's go with that. 6-4. And would you look at that? There's a file here called secret.gz. Seems to be a gzip file. Let's download the file to our matrix 3 directory, and let's unzip this gzip file. Didn't work? How about we check what kind of file this really is? The program file tells us it's a normal ASCII file, which is a text file. So let's cat it. Cat secret.gz. Hey, that's a username and a password hash. In a previous machine, we have used John the Ripper to crack a hash before. But how about we copy the hash and try to crack it online? See, there are several hash crackers online, and one of my favorites is crackstation.net. Instead of using a local word list, these online crackers have their own word lists already on their server. Okay, so we found something that looks like a password. So now we have the full credentials for, well, for somewhere. Let's echo these credentials into a file called credentials.txt. As we did see, we have a login prompt on port 7331, so let's try and use these credentials there. Okay, we are now logged in and we can view the page, and it looks like this. I've been looking at the page source, but I can't really find anything interesting there, so let's explore a different way to see if there are any more directories hosted on this web page, using a program called dirbuster. Dirbuster is a great program to enumerate directories on a web page, and as far as we know, there may be something more hidden out there. So let's try searching with dirbuster. Dirb, which is short for dirbuster, http://192.168.148.133 in my case, colon the port 7331 / because we want to know what is hidden behind the original page, -u for user credentials, and then we'll use admin :passwd. As you can see, we haven't specified any word lists here, but the word list that dirb is going to use if we don't specify one is a word list called common.txt. This is a word list containing most of the common directories and file names that can be found on any given web page. Once dirbuster is done with the scan, we found this. We already checked the directory assets. We also have an index.html, which simply gives us the original page. Something very important here is that we can see that there's a robots.txt file visible on the web page. So let's add robots.txt to the URL. In the robots.txt file, we can see that there is a disallowed entry, which is a folder called data. Dirbuster also found this folder. This tells us that something might be hidden in the data folder. So let's add /data to our URL. And inside we find a file called data. Let's download it to our matrix 3 folder. If we use the program file to check what sort of file this is, we get this. PE32 executable for MS Windows. This is a MS-DOS file. But how do we open a DOS file in Linux? If we cat the file, we can see a string saying that this DOS file is not executable. So all we really can do is check the contents of the file more closely. I will use Ghidra for this. Ghidra is a program developed by the NSA to reverse engineer files. This makes a good program to scrutinize binary files to see what's in there. Simply type Ghidra in your terminal, and Ghidra will start its graphical user interface. If you are presented with the help pages, you can simply close that window. Ghidra works in projects, so let's start a new project by going to File, New Project, and use the non-shared. Name the project, and go to File and Import File. We want to import our data file from the Vulnhub Matrix 3 directory. Select File to import. We can also see here that this is a portable executable, which we knew from before, and press OK. First, you're prompted with a lot of information about the file, but this is not what we really care about, so just click OK. Now we have opened the data file in our Matrix 3 project. Right-click, and let's open this file with the code browser. Ghidra asks if you want it to analyze the file, so let's press yes. What Ghidra then does is labeling the file, putting placeholders for starts and stops, and imports and exports and functions. This will make it easier for us to navigate through this file. I am extremely interested in one label, so let's open the labels tree and click on CLI stream user strings, or US. This is strings that Ghidra has analyzed that the user has put in themselves. If I'm going to find something interesting here, I can bet my ass that this is one of the places. Let's scroll through the code. Okay, we're starting to see some interesting text there. Welcome in Matrix version 3. Unknown device 64. Oh, and here we have it. A new credential for the user guest. So let's copy those credentials and echo them into the credentials file. Since we already have some credentials inside the file, let's just append to the file by using 2 left hyphens instead of 1. Let's also cat the file to see that we have both credentials now in the file. Perfect. Let's copy this password and try to log in on SSH on port 6464. Let's cat our scan file. Here we can see that SSH is residing on port 6464. Let's try to use our new credentials to log in on SSH on port 6464. Type yes to add the fingerprint. And now we are logged in as guest on the Matrix server. If we try some commands, we can see that we are locked in an R-bash shell, restricted bash. This is not very good. We can't use any commands, it seems. Let's check what our user path is telling us. Type export. In our path it says we have some permissions in home/guest/prog. So let's try and go there. Nope, the program CD is withheld from us. What we can do instead is trying to echo the contents of the prog folder by doing this. Here we can see that we are able to use the program V, which is a text editor. Let's do what we have done before by doing a shell escape to a bash shell. Once that is done, we can see that we can ls to check what is inside of this folder. We are in our home folder and we can see all these other folders. So let's poke through them and see if we can find something interesting inside. I found nothing, so I'll type exit. I am thrown back into V, which is the last shell that we were in. So I'll have to quit that and type exit again to return to my original terminal. We can try something else by trying to log into SSH as a guest, but anonymously. This is called a no profile login. Let's add the -t and the bash --no profile extension. This login will mean that we will SSH into the guest user anonymously and will not be restricted by the R-bash. This is simply another way to escape the restricted bash shell. Once inside, we can type sudo-l to see what our rights are. Here we can see that Trinity has the right to use the program cp, which is copy. So how can we use that to our advantage? Well, we can try to make an SSH key and use Trinity's permissions for copying to copy our public key file into Trinity's SSH directory. In turn, this will authenticate us while trying to log into the Trinity SSH. SSH-keygen. Just press enter to leave the passphrases open. And as you can see, you have created one public and one private key hosted in the .ssh directory. Let's ls-la to see what kind of rights this .ssh folder has. Only the owner has read, write, and execute rights. We need to change that. chmod 777 /.ssh. Now let's check again. Okay, anybody can do anything with this folder now. Let's cd into the .ssh folder. Here we can see that we have the public key. Let's try our super user privileges with the user Trinity to use the command copy. In the folder we're standing right now, we choose the public key file and copy that file into Trinity's authorized keys file. Trinity should now be authorizing us as we try to log in to her SSH. This is one way to leverage SSH for privilege escalation. Let's try to log in. SSH Trinity at localhost, since we are already logged into the server. -I to specify the key file that we are going to use to authenticate. -P for port 6464. Let's add the fingerprint. Okay, we're now logged in as Trinity on SSH. Let's have a quick look at our privileges as Trinity. sudo-l. We can see that Trinity can use a program called Oracle as root. But when we try to run the file, we can see that there is no such file. But we can do something very nifty here. How about we make that file, and inside the file we'll put a bash shell. We are now standing in the home/Trinity directory. Echo quotation marks /bin/sh quotation marks, and then write it into a file called Oracle. Since Trinity will run this file as root, and we put a shell inside it, we should be able to, through this shell, escalate to root. We have to think about something here. If we try to run the file simply by running Oracle, we will be able to run the file and we will get a shell, but the shell will only be run as Trinity. So we need to add sudo before we run the file. Let's type ID to see who we are now. Okay, so now we are root. That's great. If we ls in the home directory, we won't find anything. But let's go to the root directory. And there we are. We found the flag. Great work.